Hey everyone, welcome back. In the last video, we were solving problem based on extracting digits. So in the last video, we have solved this problem where we have count, sum and num. So basically we are counting the number of digits in the number and we are doing the sum of the digits. Also we are reversing the number, right? This is for counting digit and this is for summing the digits and this is for building the number, right? Means we had digits and from digits we were building the or converting to the numbers. And in the last video I left some input, right? Like this, if we have 001 as a input, our answer were sum of digits 1, reverse number 1 and count of digit 1, right? And we took another input 100, count of digit 3, right? Sum of digit 1 and reverse number 1. So I asked you how are you going to make this input work in this code. So what happens, C++ does not store 001, it automatically convert to the 1. Okay, so the only way to do it is using strings. You cannot do it directly using modulo or divide, so you have to use strings. So for strings, let's change it to the string. Okay, then for a count, now we don't have to count by looping. We can do it or we can simply use our length function, right? Because length also count the number of character in the string, so it is equivalent to the count of the digits. Okay, now we don't need the num. Okay, we can keep it and then sum. So let's change our loop. We don't need this now. For int I equals to 0, I less than n, not n, it is count, right? Because we are running the loop till last index of the string. So last index will be length of the string minus 1. Then okay, here should be integer, not a string. Okay, count should be integer because we are storing number of digits which is integer. Now we have to do a sum. So let's take single digit n of I minus 0. Okay, because our digit in the string is in the form of character, so we have to convert it to the integer first, then we can add our digit to the sum. Okay, now let's reverse our number. So num equals to, we have a reverse function for reversing, or you can make your own custom reverse function. Okay, so our num should be string. Okay, because we are storing our reversed string, so our num will be string and it is not equivalent to 0. Okay, let's see if there is any error. We have string num. Okay, we have error, we cannot assign. Okay, so what we can do here, let's remove num also. We can directly reverse our n, so here we will print our n. Okay, now let's run our code. Let's take input 001. Here you can see count of digits 3, sum of digits 1 and reversed number 100, right? Let's take 100. Here you can see count of digit 3, sum of digit 1 and the reverse number 001. Okay, so in this case you have to use string. Okay, now let's move to next problem, which is palindrome number. Okay, first you have to understand what is palindrome. So palindrome are, you can say, string or a data which you can, if you are reading from the front and if you are reading from the back, if they both are similar, then we can call them palindrome. Okay, so let's take an example. If you write a race car, okay, if you read from left to right, it is race car. If you try to read from the back, it is also a race car, right? So both of the string matches, so we can call it palindrome. If you have a number like 1 2 2 3 2 to 1 like this, if you read from left to right and if you read from right to left, the number will be same, so we can say it is a palindrome number. Basically we are checking number and reverse number. If both of them are same, we can say it is palindrome. Okay, so one method is using string itself, right? We can reverse our string, so we can compare between two strings. And our concept we are using till now, reversing a number and comparing that number with the our original number, right? In this case our problem is palindrome number. Okay, so we are not taking string, we are taking numbers. Okay, first reverse it, right? We have seen in our previous video how we reverse a number. Then after reversing, you just have to match them. If they are equal, then you can say palindrome. Okay, so let's write our code. Okay, let's remove this. Also, we don't need this. Now let's declare our number and take an input. After this, let's declare one more variable which is reversed num. Okay, then let's run our loop while n greater than 0 int reminder. Okay, I'm going to write in a single line. So reversed num equals to reversed num into 10 plus n modulo 2. Okay, then n, it is 10, sorry, it is here 10. So it is basically finding or extracting remainder from here and then adding to this number, and also it is a short form of n equals to n divided by 10. So you can write in this way also. Okay, now after reversing number, we just have to check reverse num equals to our n. If it is matches, then we can print palindrome. If it does not matches, that means it is not palindrome. Okay, now in this code there is one major mistake. Without it, it will not work. Okay, so first let's run it, then I will tell you what is the mistake. So let's take 1 2 3 2 1. Okay, here you can see it is not a palindrome, but you know 1 2 3 2 1, it is a palindrome, right? If you reverse it, it is a palindrome. Now the problem is in the end we are storing 1 2 3 2 1. Okay, right? And then here in the while loop we are dividing the same n number until it becomes 0, right? Because we are doing operation on our original n, so we are doing operation on our n itself, so n will become 0 in all the cases, right? So if n will become 0, then if you try to compare n with the reverse number, it will always give a false, so it will print not palindrome. Don't try to manipulate your original variable. Okay, so declare a temporary variable. Let's take num equals to n. So first store your original number into different variables, then you can here use that num to check if it matches or not. So let's take input 1 2 3 then 2 1. Okay, here you can see it is printing a palindrome. That means this time is our code is correct. Okay, let's take another example. 3 5 6 then 6 5. Okay, 3 5 6 6 5. Here you can see it is not a palindrome. Okay, so always remember not to manipulate your original number. The time complexity will remain same for this concept also. It will be log of n, right? Or log will be in the base of 10. Okay, so our time complexity will be log base 10 of n, or here you can say number of digits, right? Because we are jumping on the digits itself. Now let's move to the next problem, which is print factors. Okay, so now what are factors? Factors are the numbers which divides your number completely, right? If you take a 2, so 2 can be divided by 1 and 2, which will give me remainder of 0, right? So we can say these are factors of number 2. If you take 6 can be completely divisible by 1 2 3 and 6, and the remainder will be 0. So we can say these are the factors of 6. So we have to print all the factors. Okay, so let's see how we are going to do it. So our question is print factors. So factors basically are the numbers which completely divide a number. So let's take 6. What are the factors of 6? 1 2 3 and 6, right? If you take a 7, what are the factors of 7? 1 and 7 itself. Then take 18. What are the factors? 1 then 2 3 6 9 then 18, right? These are our factors for 18. 1 is always dividing this number. Okay, so if you take any numbers, 1 will always be dividing them, so 1 will always be the factor. So these are the factors. Now we have to print these factors. So how we can do it? So basically we have number n which is 18. We need something which can check if the remainder is 0 or not, right? If the remainder is 0, that means that number is completely dividing it, right? Let's say if you have taken 5, if you try to divide 18 with the 5, then the remainder will remain 3, so it is wrong. If you take a 18 and try to divide by 9, then our remainder will remain 0. So we are targeting the numbers which will give us remainder 0, right? So we have to take a modulo to find the remainder. So now we are checking with the different numbers, right? So we have to iterate over these numbers. For this we have to use our loop, okay, and we have to check this condition. Okay, let's write code, then we will dry run it. So first we have our number int n scene n. After this we will loop over the numbers, then I from starting 1, right, then I less than equals to n I plus plus. Here we are starting from 1 because we cannot take a 0 as a factor, so, and it is not also possible because you cannot divide a number with 0, it will leads to infinity. Okay, so we'll start our loop from 1 and we will go till n means the number we are giving as a input. So we are giving 6, then it is going till the 6, 7 7 18 18. So the number itself also a factor, right? That's why we have started from 1 to n. After this we will check if number n modulo I equals to 0, we will print our number which is I. Okay, so this is our code. Now let's dry run it. So let's take our number 18. So we have I equals to 1, right? If you do a 18 modulo 1, it will give you 0. So 0 equals to 0, condition true, then it will print your answer which will be 1. Then loop will continue and I will become 2. Now again 18 modulo 2 will become remainder 0, then 0 equals to 0, condition true, so it will print your 2 here. Then I will become 3, then 18 modulo 3, it is 0, right, then 0 0 equals to true, condition true, then it will print 3. Now I equals to 4, then 18 modulo 4, it is 0, no, there is I think remainder of 2, 2 equals to 0, no, false, so it will not print 4 here, okay, because it is not a factor. So that's how our code is working. Now let's talk about the time complexity. It is simple, right? It will be big of n because we are running our loop from 1 to n. That means we are iterating from 1 to n till the number for which we have to print factors. Time complexity will be n and space complexity will be 1, right, because we are only using a variable and variable takes only big of 1. Okay, now how we can improve our time complexity to the log n. Okay, so let's see how. So you have here I which you are starting from 1. What number should I multiply here? So it will become equivalent to 18. So 18 itself, what number should I multiply here? So it becomes 18, 9, right? Then we have 3, what number should I multiply? 6. Then 4, what number should I multiply? Not possible. Then 5 into 18, not possible. 6 into 3, 18. Then 7 into, not possible. Then 8, 9, 10, dot dot dot. So here you can see these are the possible numbers we can multiply, it will become equals to 18. So let's remove this. Now here you can see after this number we are kind of repeating things, right? Because at the end it will reach till 18 and we have to multiply 1, then it will become 18. So if you look at that, it is similar, then it is similar, then it is similar, right? So that means after this partition the numbers are repeating itself. And if you look at it, our factors of 18 are 1 2 3 6 9 and 18. These are the factors. If you observe it, 1 2 3 6 9 18, these are the factors which we have to print, and these are above the line. That means we don't have to go till the end, we can go till the 3 itself, okay, or we can say we have to go till only root of n. Okay, so if we have here 18, so what will be the root 18? So it will be around, if we take a 16 here, it will be 4, right? So maybe somewhere 4.56 or, right, but we have to go till the 3. So you can see we just have to go till root n. Beyond that we don't need to go, because you can see we are able to find all the factors till the root n itself. Okay, one more thing, here our time complexity is not log n, it will be root n. Okay, sorry for the mistake, it will be root n. Okay, so here we have I, here we have I and divided by I. So 18 divided by 1, 18, 18 divided by 2, 9, 18 18 divided by 3, it will be 6. So we have I and n divided by I. So we have to print these. Now let's write the code. So I'm going to start for int I equals to 1, I into I less than n I plus plus. Okay, here we are writing I less than root n, so I can write I squared less than n, then I into I less than n, right? So that's what I have written. Or you can also write like this, I less than sqrt of n. Okay, this is inbuilt function in C++, so you can write like this or you can write like this. Prefer to write like this because we are trying to minimize the use of inbuilt function, right? So you can use any way. After this we are checking n modulo I equals to 0, right? So we can print our I. Now print n divided by I, right? This will print my all factor. Okay, now let's run, and there is one more thing we have to fix in this code. Before that, let's run our codes. Okay, let's remove these. We will be taking a number n, then we will be running a loop from 1 going till n, then if n modulo I equals to 0, if remainder is 0, then we can say it is factor. Okay, this is our first code which had a time complexity of n. So let's run it. Let's take a input of 18. Here you can see 1 2 3 6 9 18. Let's take another example. Let's take 25. Here you can see 1 5 and 25 are the factors. Now let's write our code with the time complexity of root n. So our loop will start from 1 itself, then it will go till I into I less than n. Then we will check if that number is factor or not, and also we will print n divided by I also. Okay, so let's run it. Let's take 18 again. Here you can see 1 2 3 6 9 18. Okay, in this case there is no sequence, means it will not print in a ascending order, because for 1 we are taking 18, for 2 we are taking 9, for 3 we are taking 6, so it is kind of making a pattern. Okay, let's do it like this. Okay, let's print it, and 18. Here you can see for 18, 1 into 18 18, 9 into 2 18, 3 into 6 which is 18, right? Now let's take one more example, which is our 36. 4 36, 1 into 36, 2 into 18, 3 into 12, 9 into 4. Now there is one factor is missing, which is 6. If you multiply 6 into 6, it is also 36, right? So we will go till I less than equals to n, right? Because if you take a root of 36, it will become 6 itself. So we will go till the n itself less than n. Okay, now let's run it. 36. Now 1 into 36, 2 into 36, 3 into 12, 4 into 9, then 6 into 6. Now it is wrong again, right? Because we need only one factor. Here it is printing two factors. So for this we have to write one more condition here. If n divided by I not equals to I. Okay, let's run it. So here you can see now it is printing me only unique factors. So what is this condition and how it is working? Okay, let's see here. So this is our number 36. So 1 into 36, which is 36, 2 into 18, 36, 3 into 12, 36, 4 into 9, 36, 6 into 6, 36. After this our number will start repeating. Okay, and here we were taking I here n divided by I. So here you can see in I also we are getting 6, in n divided by also getting 6. So in one of the cases we have to eliminate our 6, so that's why we have written a condition n divided by not equals to I, means here 36 divided by I or 6, it will become 6, and I also 6, so I not equals to 6. This should be the condition, means if they are not equal then print, means condition true. If they are equal, that means condition false, that means do not print. If you take this n divided by I not equals to I, so I is 4. For this case our I is 4. So 36 divided by 4 not equal to value of I here 4. So it is 9 not equal to 4. 9 not equal to 4, true. Then it will print our 9 also. Okay, so this is our condition to ignore the duplicate factor. Okay, let's let me write here also, if n divided by I not equals to I, also here less than equals to. Okay, this is our final code, and our time complexity is root of n, space complexity is big of 1. Okay, so for today that's it. In the next video we are going to solve more problems on maths. Until then, thank you everyone, have a nice day.